Bright Tuty. Every student matters.
Next is what is a molecule. We had learned what is an atom, the smallest particle of a matter. And we know that every matter that we see around us are made up of these atoms. But are these atoms stable? These atoms are not stable. They are very, very active. So they do not exist as individual ones. They rather would like to stay in combination. What I mean to say is that they combine together to form molecule. Now what is a molecule? A molecule can be defined as the smallest particle of an element or a compound that is capable of independent existence and shows all the properties of that substance. Alright, now here what it means that if you have a molecule, it can be a molecule of an element or a molecule of a compound. Molecule is such a particle in which two or more atoms come together and they have individual existence. Individual existence of atom may not be possible, but molecules always exist individually because they are not single atoms, they are in combination of atoms. It can be two or more of the same kind or different kind. Alright, so I repeat, what is a molecule? A molecule can be defined as the smallest particle of an element and compound or a compound that is capable of independent existence. When it is in molecular state, it does not react. Whereas when it is in atomic state, there is every possibility of reaction because it is very, very unstable. Whereas a molecule is a stable state and it shows all the properties that the substance has. For that, the molecule can be of two types, the molecule of an element and the molecule of compound. Now, if it is a molecule of an element, that means the atoms are going to be of the same kind and of the same properties. For example, if I take molecule of hydrogen. Molecule of hydrogen means hydrogen is made up of two atoms and these two atoms combine together to form a molecule of an element. And these two atoms are exactly of the same kind and the hydrogen molecule will have all the properties that hydrogen has in the atomic state. The only difference is hydrogen atoms are unstable and the molecule is stable. But the physical property, chemical property are going to be exactly the same. Similarly, if we take chlorine molecule, there you would see there are two chlorine atoms that combine to form a molecule of chlorine, which is the stable state. I can take another example. For instance, if I take oxygen, then oxygen is made up of two atoms of oxygen. Whereas there can be a molecule of ozone, where there are three atoms of oxygen combines together to form a molecule of ozone. And in each of these cases, you would see the same kind of atoms combined together. So when we need to define a molecule of an element, then we would define that a molecule of an element is the smallest particle in which two or more atoms of the same kind combines together to have an independent existence and it has all the properties that an element shows. Whereas when we come to a molecule of a compound means when two or more same kind or different kind of atoms combine together, then we call it as a molecule of a compound to have an independent existence. Now for instance, here I can take carbon dioxide. So if I take carbon dioxide, it is composed of one atom of carbon whereas two atoms of oxygen and these combines together to form a molecule of a compound. But in case of molecule of a compound, you need to understand that the atoms of the elements are different. There are two or more different kinds of atoms which comes together and they start behaving like the same. So carbon will lose its entity, oxygen is going to lose its entity, they are going to combine to form carbon dioxide, and this new substance, this new molecule that is formed will have all the properties of carbon dioxide. Okay, so we had seen the molecule of a compound, molecule of an element. Now what is this term called atomicity? Atomicity means the number of atoms that is present in a molecule. I repeat, number of molecules present in the number of atoms present in a molecule is known as atomicity. It can be a molecule of an element or a molecule of a compound. So I repeat, the number of atoms present in a molecule is known as the atomicity. Now if I ask you what is the atomicity of nitrogen, the formula of nitrogen is N2, so the atomicity is 2. Why? Because there are 2 atoms of nitrogen that combines to form a molecule. What is the atomicity of ozone molecule? It is 3, right? Why? Because 3 atoms of oxygen combine to form ozone. So nitrogen is known as diatomic because there are 2 atoms, whereas ozone is known as triatomic. Now you would question, do we have any monoatomic? Yes, of course, we do have monoatomic atoms as well, or monoatomic molecules. Now what happens, noble gases are such, or inert gases, what they are called as well, they exist in the atomic state. So we did not have a molecule, in fact they exist in single atomic state because they are stable at the atomic state, and we have only 8 such elements. So we can have helium, which is a monoatomic with only 1 helium atom, and thus it is monoatomic. What will it be for CH3 or CH4, which is methane? It is a compound. What is atomicity? Yes, 5, because there are 5 atoms, 1 of carbon and 4 of hydrogen. But what would be NH3, ammonia? Atomicity? Yes, it is 4. It is tetraatomic because there is 1 nitrogen atom and 3 hydrogen atoms. So you have understood what is atomicity. Atomicity means the number of atoms present in a molecule, either of an element or a compound. So we had taken these examples: nitrogen, 2 atoms, so it is diatomic; ozone, 3 atoms, triatomic; helium, only 1, so it is monoatomic; methane, 5 atoms, that is, it is pentaatomic; ammonia, 4 atoms, so it is tetraatomic. Alright, so I hope you had understood what is a molecule. I repeat, a molecule can be defined as the smallest particle of an element or a compound that is capable of independent existence and shows all the properties that a substance contains. Fine? Okay, now let's go to the next question. Find the ratio by number of atoms of elements in the molecule of compounds: water, ammonia, carbon dioxide, so on. Now in this, what happens, in this question you can see that the ratio by numbers of atoms is given. That is, the ratio is 1:8. In ammonia it is 14:3. Now for solving such problems, this is how we are going to do. Let us start with the first one. Let us take water, whose ratio is given to be 1:8. Now they say that find the ratio by number of atoms. We have to find out the ratio by number of atoms of the molecule of a compound who has a ratio between hydrogen and oxygen to be 1:8. So for that, first we need to draw a table. This is our element. This is ratio by mass. Then we are going to take into account atomic mass. Because we need to find out the ratio by number of atoms, so it is going to be mass ratio, that is A, and if this block is B, then mass ratio A divided by atomic mass, which is B. And then ultimately we will get the number of atoms, or rather just the number. Alright, so this is how we are going to make it. Now let us start doing it. Now what are the elements in this compound? We have two elements, hydrogen and oxygen. Ratio by mass, what is it given? It is given that hydrogen is 1, whereas oxygen is 8. Now we know the atomic mass of hydrogen is 1, so we are going to put it 1, and the atomic mass of oxygen is 16, so 16 is put up here. Alright, after that we need to divide A by B, that means 1 divided by 1, and this one, it is 8 by 16. So what is the answer going to be? 1, and this is half. Now we know that atoms cannot be in fractions. This is what John Dalton said. So because we are finding out the number of atoms, so the number cannot be fraction. Atoms cannot be fractionated because it is indivisible. And whenever they are combining in whole numbers. So what do? We will try to convert this fraction into a whole number. How would you do it? We would multiply both the terms with 2. So this becomes equal to 2 and this will come to 1. That means the ratio by number of the atoms of the element in the molecule of compound hydrogen. So we have hydrogen with 2 and oxygen is O. So we find the chemical formula as H2O. So you had seen how we made the conversion. What did we do? We plotted a table. First we took up element. What are the elements required? Then we took the ratio by mass, which is already given in the question. Atomic mass is a constant term which you already know. Then we divided the mass by atomic mass. And then we converted into whole numbers, and this is what we get. Let's do the next one of nitrogen and hydrogen. So let me continue with the same one. All we need to do, I don't need to make the table again. I will be just using the same table. We will just fill in the ratios and the elements. Let us see what is the ratio by number of the atoms of elements between nitrogen and hydrogen. So what are the elements? We have now nitrogen and hydrogen. What is the ratio given? Nitrogen, for nitrogen it is 14 and for hydrogen it is 3. Atomic mass of nitrogen is already known to be 14, whereas for hydrogen it is 1. Okay, so if I divide A by B, it means 14 divided by 14. In this case, 3 divided by 1, which is equal to 1, which is equal to 3. So the number is 1 and 3. We do not need to convert it into a whole number because it is already in whole numbers. Thus, the ratio by number of atoms of the elements of nitrogen and hydrogen is N is 1, H hydrogen is 3. That is, ammonia has a chemical formula of NH3. So likewise, you can also solve for carbon dioxide. Okay, I hope this is clear to you. Alright, so this is how we apply the ratio by number to find out the number of elements.